Hey everyone, my name is Dan and I'll be discussing the concept of an electrical field. The electrical field is defined as the electrical force per unit of charge. The direction of an electrical field is the direction of the force it would exert on a positive test charge. Since the electrical field is a vector quantity, it can be represented by a vector arrow. For any given location, the arrows point in the direction of the electrical field and their length is proportional to the strength of the electrical field at that location. Note that the lengths of the arrows in this diagram are longer when closer to the source charge and shorter when further from the source charge. A useful means of visually representing the nature of an electrical field is through the use of electrical field lines of force. Rather than drawing many vector arrows in the space surrounding a source charge, it is more useful to draw a pattern of several lines that extend between infinity and the source charge. In order to properly represent the information about the direction of the field, each line must include an arrowhead that points in the appropriate direction. An electrical field line pattern could include an infinite number of lines. However, the presence of a few lines around a charge is typically sufficient to convey the nature of the electrical field in the space surrounding the lines. Some things to note when drawing electrical field patterns. One common convention is to surround more charged objects by more lines. Objects with greater charge create stronger electrical fields. By surrounding a highly charged object with more lines, one can communicate the strength of an electrical field in the space surrounding a charged object by the line density. In this diagram, two different circular cross-sections are drawn at different distances from the source charge. These cross-sections represent regions of space closer to and further from the source charge. Second rule for drawing electric field lines involves drawing lines of force perpendicular to the surface of objects at the locations where the lines connect to the object's surface. And lastly, electrical field lines cannot cross each other at any given location in space. Thank you for your time.